In dense visualizations, such as time series, node-link diagrams, and parallel coordinates, it can be challenging to select a subset of curves. Common techniques based on rectangles and brushes can result in selections that overlap with non-desired curves, requiring correction to obtain the desired subset. For example, the user may need to draw two rectangle selections or two brush strokes to select the subset of curves passing through both. To address this issue, we propose a novel single-drag angular selection technique. Our solution is more precise than conventional approaches and allows easy selection of bundles of curves oriented in the same direction. Our angular selection widget calculates the tangent vector at each intersecting point with the lens. Curves are selected only if the slope of their tangent vector fits within the angular tolerance defined by the gray cone. This tolerance is inversely related to the distance between the center of the lens and the mouse cursor. As the user drags further away, the selection becomes more precise. Our technique only considers curves under the lens, which limits the selection to a constrained region of interest. The size of the lens can be adjusted with the scroll wheel. We also implemented a hybrid approach, where the lens acts as a simple brush if the user clicks and releases inside the lens. This technique allows for faster selection when selecting within a sparse region. The user still optionally drags outside the lens to perform angular selection. We compared these four techniques experimentally. For each one, the user completed a series of trials. Each trial required the user to select a highlighted subset of target curves as quickly as possible. The user could complete each trial by successfully selecting the target curves with a single mouse stroke, or by correcting their initial selection with additional subsequent mouse strokes until only the target curves were selected. The total time to use the angular and hybrid selection techniques were slower than the brush and rectangular techniques, with the hybrid being 12% slower than the rectangle. However, the angular and hybrid selection were the most successful techniques at performing error-free selections in a single mouse stroke. They also resulted in significantly fewer errors over all trials. The hybrid technique was also the most preferred subjectively, despite the fact that users had no previous experience with the angular or hybrid techniques, but did have some extensive previous experience with rectangle and brush selection. We implemented an application for visualizing financial time series data and created a novel VectorLens widget that extends the previous techniques. Our VectorLens subsumes the hybrid selection technique and enables brush selection, angular selection, directly clicking on curves, and selecting based on data categories. The user may also click and drag to perform angular selection. This also instantiates a vector lens that remains visible for subsequent adjustments to the selection. The user may adjust the tolerance by dragging within a ring or by dragging outward to repeat the angular selection. The user may also add additional angular range on either side of the widget, which is useful when focused on changes before or after the lens, or even delete angular range with a right click. The user may reposition the lens, causing the angular range to be applied to the new content under the lens. The radius is changed with the scroll wheel. As with the hybrid selection technique, the user may also simply click and release to create a vector lens that has all curves within it selected. The user may also click directly on a curve to select it. An additional way to perform selection is through one of the categorical pop-up lists. For example, hovering over the list of clients causes the corresponding curves to be highlighted and allows us to select individual clients of interest. Now, the list of sectors shows only those sectors corresponding to the previous chosen clients. Selecting one of these sectors further refines the selection. We can also remove the selected clients, in which case the VectorLens still remembers which sector was chosen. We can then add angular selection criterion to refine the selection. Finally, multiple VectorLens widgets can be instantiated, causing the intersection of their respective criteria to be selected.